Everyone, hope you all are doing well. Today we are going to see about the searching algorithms. Searching and sorting algorithms are the two important algorithms in programming languages, and coming for placements perspective as well, these two algorithms are most asked questions. So let us look at what is searching and what is binary searching. So let us so we are going to see binary search today. Binary search. Okay, so let us take a list which contains 2, 3, 4, 9 and 11. Okay, so in this we need to find the index value of 9. So this can be done in a normal way by using the for loop. We are going to iterate through the list and we'll search for the number and we'll return its index value. So let us make it clear by drawing the boxes for list. So 1, 2, 3, 4, 7, 9 and 11. So the index starts from 0, 1, 2, 3, 4 and 5. So in normal for loop, which is called as a linear search, in this we are going to run a for loop. Let us see roughly about this, and later we'll look the code of this also. So for I in range, we'll check for I in range the length of that list, and we'll take a condition and we will check the list of that I is equals to the x. Here x is the target value, where x is equal, here x is 9. So it will search for that. If it is present, it will print the index value, else it will print element is not present in the list. Okay, so let us look the code of this. We're in the Google Colab. Let us run the code for that the approach which is using by for loop, which is also called as a linear approach, linear search. So in this we'll consider list 1, which is equals to 2, 3, 5, 7, 8, 11. So what is the length of this list? 1, 2, 3, 4, 5, 6. The length of the list is 6 and the index position start from 0. So we will take a target value from the user, which will be an integer. So input will ask user to enter target value. Okay, and we will implement this in a for loop for I in range of length of the list 1. Okay, and we'll take a condition and we will check whether the list 1 of the iterating value I is equal to the target value x. If it is so, we will tell them to print the index position of the target value is I. So let us run this code. So it's asking the target value. So I want to find the index position of that 8. So let us take 8. So the index position of the target value is 4. So see, it's 0, 1, 2, 3, 4. So we got the right answer. But still we are not going for this approach, as this code takes n number of iteration and we are using a for loop. So we're going to, the time complexity of this code will be order of n. So to reduce the time complexity of this code, we are going for the binary search. So let us look what is binary search. So we will see what is binary search. So to understand binary search, we will look through an example. So binaries, as we saw the linear search before. In linear search, if the array is not sorted, then also the program will run. But for the main prerequisite for binary search is it should be a sorted array. It should be a sorted one. So this is a sorted list. So let us take the index positions of this list, each element 0, 2, 3, 4, 5, 6, and so on, which is having the length n. Here n is equals to 10. So let us understand how the binary searching principle is working principle of binary search. So in binary search there are three cases. So let us say how binary search works. The binary search works in the manner of divide and rule policy. So in binary search we are going to divide the whole list and we are going to check, we are going to divide the whole element, and we will say this is left and this is right, and this one is middle. So we are going to divide the whole list and we are going to compare it with the middle. If it is equal to middle value, we'll return it. Else if the target value is greater than the middle value, then we'll move on the right side, and we'll ignore this one. We'll ignore this part. So if the element is less than of the middle value, if the target is less than the middle value, we'll go this side and we'll ignore this part. Okay, so let us say how it works. So let us write down the conditions. So case case one is if the list of that middle value is equals to the target, then return mid. The case 2 is if the list of mid is greater than the target, then if the middle value means if the target is less than middle value, then we'll move to the left side. If we are moving to the left side, then the right becomes m minus 1. So right is equals to mid minus 1. Okay, so the third case, if the list of mid is less than the target value, then the low is equals to mid plus 1. Okay, so let us check it for the each cases. So let us make the columns for left, right, and mid. Okay, so this is left, this is right, and this is mid. So let us say what is left. L is always equal to 0 because as we are starting from the 0 position, 0 index, and the right will be length of the list minus 1, and the middle value mid is equals to L plus R truncated division by 2. Truncated division because we will not take the pointer value. So for to take the integer value, we are going for truncated division. So let us search for the number 17. Okay, the target value is 17. Target is equals to 17. Okay, so for 17, what we are going? We are going in the case 1. We are going to check if the middle. So what is the middle value now? It is 0, and the right. This is 10, and the right is 9. Whole divided by 2. What you will get? We will get 2 by 4. 2 4s are 8. Okay. So mid is equals to 4. So now L is equals to 0. R is equals to 9. So the middle value is 4. So coming for the, so let us check this in three conditions, in these three cases. So when the middle value is 4, So the middle value element is 13. So 13 is equal to the target? No. The target is 17, right? So the target, let us write the target somewhere else here. Yeah. The target is 17. This is our target. So 13 is less than 17 because this is a sorted array. So we have to move to the right side to get 17. So when the middle value is less than the target, the low becomes mid plus 1. So now the low is mid. What is mid? Mid is 4. So mid plus 1 is 5, low is 5, and right is 9. So what will be the middle value now? 14 by 2, which is 7. So now 7 is the middle value. Okay. So this 24, we will check again in these three cases. 24 is equals to 17. No. Next case, 24 is less than target. No. So the third case, 24 is greater than the target. So now the low value remains the same. The right value becomes mid minus 1. What was mid? 7. Mid minus 1, 6. So 5. So the middle value 5 plus 10, 5 plus 5, 10. So 10 plus 1, 11. 11 by 2, which is 5. Truncated division will get 5. So now the middle value is 5. So now the mid is 5. Again we'll check for the conditions. So it is 14. So this condition will fail. We will go for the next condition. The middle value is less than the target or greater than the target. So 14 is less than 17. So we will take mid, low is equals to mid plus 1. So here we will write mid plus 1. This becomes 6. The right will be as it is 6. 6 plus 6, 12. 12 by 2, 6. So now 6 is the low value. 6 is the low. 6 is the right, left and right. 6 is as well as mid. So what is the sixth one? This is 17. The value of sixth index is, the value is 17. So the condition satisfies and it will return mid. So this is the approach for the binary search. So let us implement this in coding. So as discussed in the Jamboard, so let us see how to implement the binary search algorithm. Okay, so let us define a function named binary search, which takes the list 1, comma the low left, comma right, comma and the target value. Okay, so in this we are going to take a while loop, and because L left should be always less than or equal to right. Yes, it will be 0 or else it will become equal to right when it is a middle value. So in this condition only the three cases works. So let us define what is mid. Mid is nothing but L plus R truncated division 2. Let us put this in brackets. Okay, so let's start making the three conditions. So the list 1 of mid is equals to target value X. What we'll do, we'll return the mid, else elif the list 1 of mid should be great. If it is greater than the target value X, we will make R is equals to mid minus 1. I will make mid minus 1 because as the target value is less than X, so it will move to the left side. So the right value, which is 9, it will become mid minus 1. So let us take the last condition. elif list one of mate, list one of mate, and loop where in this condition what happens? We will ignore the left side and we will move on to the right side. So the low which will be 0, that will be mid plus 1, mid plus 1. So the three conditions have been written. So if these three conditions doesn't work, means the element is not present in the list. So for that, let us return, for now let us return it as -1 if in that case. So let us call this function now. For that, we'll define what is our code, what is the list one and all. So this will be the driver code. This will be the driver code. So let us define what is list one. List one was 3, 7, 9, 11, 13, 14, 17, 24, 41, 70. Right. So we'll call a function and we will store it in the variable called result. So the result will be a binary search. We're calling this function as binary search and takes list one which is defined above, and the low will be 0. How we'll calculate right is equals to the length of list 1 minus 1 comma, so target. So as we explained in the white paper for the number 17, so we searched the number 17 in the white paper. So let us see it is working or not. So I am taking 17 here. So we'll take a condition. If the result is returning us a -1, that means the element does not present in the list. So we will make a result is not equal to the, let us take a condition which is result is not equal to -1, then we can print the element, the index value of the target element of the target element is result. Next, else what we will do, else the element is not present. So else we are going to print element is not present in the list. So we will run this. Okay, it's giving us the index value of the target element is 6. Which one we got? We got here. So what was the middle value? It was 6. It was 6, right? So yeah, here also we got 6, and here also we got 6. I hope you understood the how does the binary search works. So let us speak about the time complexity of this algorithm. So the time complexity of this algorithm is order of log n. So let us check for the other value as well. So So we will change, we'll check the index of 24. What is the index of 24? See, 0, 1, 2, 3, 4, 5, 6, 7. It's coming 7, right? So yeah, let us check for 3. 3 is in zeros index, so we are getting the value. So this is all about binary search algorithms. So binary search algorithm is very helpful wherever you need to search a number, wherever searching is required. So kindly look to the binary search algorithm and prepare well for the binary search algorithm. So that's all about binary search algorithm. Thank you.